On July 1st, 2025, astronomers in Chile made a groundbreaking discovery. They detected a rare interstellar object, 3I/Atlas, marking only the third time in history that such a visitor has been confirmed entering our solar system. The excitement was palpable as telescopes across the Atacama Desert turned their gaze skyward, eager to catch a glimpse of this cosmic wanderer from the depths of interstellar space. Unlike local comets, 3I/Atlas followed a hyperbolic path, racing through the solar system at a staggering 137,000 miles per hour. This incredible speed and trajectory proved it was not bound to our sun, but simply passing through. An interstellar traveller on a one-way journey. Following in the wake of Oumuamua and 2I/Borisov, 3I/Atlas offered a rare opportunity to study the diversity of objects that roam the galaxy. Each interstellar visitor brings with it secrets from distant star systems, carrying clues about the environments where they formed and the forces that shaped them. As telescopes worldwide tracked its approach, astronomers collaborated across continents, sharing data and observations in real time. Early findings hinted at something truly strange, anomalies in its composition and behavior that defied our current understanding of cosmic chemistry. The light from this mysterious visitor told a story that challenged everything we thought we knew about natural objects from deep space. Its spectrum revealed unexpected elements and compounds, raising new questions about how such objects form and survive the journey between stars. The scientific community braced for a mystery that would upend expectations, sparking debates and inspiring new theories about the origins of interstellar objects. 3I/Atlas was about to become the most puzzling interstellar visitor yet, promising to reshape our understanding of the universe and our place within it. Spectroscopic analysis from the Very Large Telescope revealed a shocking detail. 3I/Atlas was venting nickel into space, but with a twist. There was no trace of iron at all. This was not just unusual, it was unprecedented in the annals of astronomy. The data left scientists both excited and deeply puzzled, as it challenged everything they thought they knew about the chemistry of celestial bodies. In nature, nickel and iron are forged together in the heart of dying stars, created side by side during the cataclysmic explosions of supernovae. These elements are cosmic siblings, always found together in meteorites, asteroids and planetary cores. Their separation is almost unheard of, making the absence of iron alongside nickel in 3I/Atlas a true cosmic anomaly. Even more astonishing, the object was shedding nickel at a rate of 5 grams per second and cyanide at 20 grams per second. This chemical profile was unlike anything ever recorded in natural comets or asteroids. The sheer volume and combination of these substances suggested a process far more complex than simple outgassing or solar heating. This iron-free nickel, paired with a surge in cyanide, bore a striking resemblance to the byproducts of industrial refining here on Earth, rather than the expected results of cosmic processes. It was as if the object had been processed or altered by some unknown mechanism, raising profound questions about its true nature. Some scientists quietly wondered, could this object have been shaped by technology, not by the slow hand of nature? Was it possible that 3I/Atlas was evidence of something artificial, perhaps even a relic of alien engineering drifting through our solar system? The chemical evidence forced a radical rethinking of 3I/Atlas's origins. Theories that once seemed outlandish were now being considered seriously as researchers struggled to explain the object's bizarre composition and behavior. Was this a fragment of alien industry, a piece of advanced technology lost to the void, or simply a new kind of cosmic body that defied all previous classification? The possibilities were as thrilling as they were unsettling. The mystery deepened with every observation, leaving astronomers eager for answers and the world watching in anticipation. The James Webb Space Telescope and Sphere-X soon revealed another anomaly. 3I/Atlas's coma was 95% carbon dioxide and only 5% water. Typical comets are rich in water ice, but this one was almost entirely CO2, a bizarre, almost unthinkable composition. Combined with the iron-free nickel, this suggested 3I/Atlas was not just unusual, but possibly engineered. Its materials and proportions didn't match any known natural process. Each new finding pushed scientists further from conventional explanations. Was this object a product of alien technology? The evidence was mounting, and the questions were growing more profound. The object's trajectory added another layer of intrigue. It was perfectly aligned with the ecliptic plane where all our planets orbit. For a random interstellar visitor, this alignment is astronomically unlikely. Some, like Professor Avi Loeb, wondered if this was coincidence or deliberate targeting, exactly the path a probe would take to study a planetary system. The alignment combined with the chemical oddities made the case for artificial origin harder to dismiss. Was 3I/Atlas sent here on purpose? While chance can't be ruled out, the convergence of so many anomalies was impossible to ignore. The object's path forced scientists to confront unsettling possibilities. Was it aimed at us? 3I/Atlas was far brighter than expected. Either it was a colossal object or it had a dense reflective coma. If it was massive, it would be a statistical outlier, dwarfing any known comet. If it was small but surrounded by dust, it should have a visible tail. Yet Hubble images showed no tail at all, contradicting both explanations. The object was too bright for its apparent size, but lacked the features of a typical comet. This paradox left astronomers baffled. Was it a solid body or something else entirely? Perhaps a thin, reflective structure. The physical evidence refused to fit any natural model. 3I/Atlas remained an enigma. Scientists are split. Is 3I/Atlas a bizarre natural comet or a piece of alien technology? Some argue it's simply a new class of interstellar object formed in conditions unlike anything in our solar system. Others point to the industrial-like chemistry, the perfect trajectory, and the brightness paradox as evidence of technology. Could it be a probe, a solar sail, or a derelict fragment from another civilization? The timing is curious. Its journey began around the time humanity started broadcasting radio signals into space. Nobel laureates have even suggested listening for transmissions. The debate is no longer just about astronomy, it's about our place in the universe. History warns us to be cautious. The search for cosmic signals is filled with excitement, but also with the risk of misinterpretation. Every generation of astronomers has faced moments of hope and disappointment, learning that the universe is often more complex than it first appears. The famous "wow" signal of 1977 once seemed like proof of alien contact, sparking imaginations worldwide. For a brief moment, it felt as if we had finally received a message from another civilization. But after years of investigation, it was later explained as a natural astrophysical event, reminding us how easily we can be misled by the unknown. The universe often mimics the signs of technology, producing signals that can appear artificial. This is why rigorous skepticism is essential, and why scientists must always question their assumptions, no matter how compelling the evidence may seem at first. The anomalies of 3I/Atlas are real, and they challenge our understanding. But extraordinary claims demand extraordinary evidence, and we must be careful not to let our hopes outpace the facts. We must exhaust all natural explanations before leaping to conclusions. Only by methodically ruling out the ordinary can we truly recognize the extraordinary. The story of the "wow" signal reminds us the cosmos is full of surprises and our ignorance is vast. Each mystery is a lesson in humility, showing us how much we still have to learn. 3. I/Atlas may be a natural object we don't yet understand. A puzzle piece that doesn't quite fit, but that doesn't mean it's evidence of something beyond nature. The temptation to believe is strong, especially when faced with the unknown, but the duty to verify is even stronger. True discovery comes from discipline and careful analysis. Science demands patience and rigor, even in the face of cosmic mystery. Only by holding ourselves to the highest standards can we hope to uncover the true wonders of the universe. The truth about 3 I/Atlas will come from data, not speculation. On October 3rd, 2025, it will pass close to Mars, giving the Mars Reconnaissance Orbiter a chance to capture high-resolution images. These images could finally reveal its true size and nature, resolving the paradox of its brightness. As it nears the Sun, telescopes worldwide will gather every possible clue about its composition. Whether it's a bizarre comet or the first evidence of alien technology, 3 I/Atlas is a scientific milestone. Its journey reminds us how much we have yet to learn about our galaxy. The search for answers unites us all in wonder and curiosity. Stay tuned as we await the secrets of this silent traveler from the stars.